The workhorse of the urinary system are the kidney, which are the twin being sharp organs in your body that clean harmful substances by filtering your blood. They are like a water purification plant that help clean the drinking water acidity. They also regulate blood pH, volume, pressure, osmolality, uh, osmolality, as well as produce hormones. The kidneys are located between the T12 and L3 vertebrae and by ribs 11 and 12, which are the floating ribs. The kidneys are roughly the size of first and are retiperitoneal, meaning they sit behind the peritoneal membrane alongside the vertebral column. The right kidney is pushed down by the liver, so it sits slightly lower than the left kidney. In the middle of the kidney, there is an indentation that forms the renal hilum. This is the entry and exit point for the ureter, renal artery and renal vein, lymphatics, and nerves go into and come out of the kidney. The kidney is surrounded by three layers of tissue. One, the outside, is the renal fascia, which is a thin layer of the kidney, anchors the kidney to its surroundings. The middle layer, the adipose capsule, is a fatty layer that protects kidney from the tumor. The lipid layer, called the renal capsule, is a smooth, transparent strip of denser connective tissue that gives the kidney its distinctive shape. If you take a cross section of the kidney, there are two main parts. The inner portion is the renal medulla and the outside rim is the renal cortex. The medulla is made of 110 to 18 renal pyramid, with the base of the pyramid facing the renal cortex and the tip of the pyramid called renal papilla or nipple pointing to the center of the kidney. The renal papilla projects into minor calyces, which join together to form major calyces, which funnel into the renal pelvis. Urine collects in the renal pelvis and then heads out of the kidney. The renal cortex can be divided into an outer cortical zone and an inner zones. There are also sections of the cortex called renal colons, which extend medulla separating the renal pyramid from one another. Each renal pyramid and the renal cortex above it is called the renal lobe. So an adult kidney filters about 150 liters of blood a day. If we assume that there are 5 liters of blood in the body, that means that the entire volume gets filtered about 30 times a day, which is more than once every hour. Because of this, the kidney gets about a quarter of the cardiac output, which is blood getting pumped out the left ventricle. To reach the kidneys, blood flows from aorta into the left and right renal arteries. As these renal arteries enter the kidney, they divide into segmental arteries, then into internal arteries, which pass through the renal columns, then to arcuate articles, bases of the renal pyramid, and then to cortical radiate artery, which supplies the cortex. The cortical radiate arteries continue to divide, eventually form afferent arteries that split into a tiny bundle of the capillary called the glomerulus. The glomerulus is the site where blood filtration starts. Interestingly, once the blood leaves these glomeruli, it does not enter into the venule. Instead, the glomerulus funnels blood into afferent arterioles, which divide into the capillaries a second time. These peritubular capillaries then unite to become the cortical radiate veins, then the arcuate veins, then interlobular veins, and finally into the left and right renal veins, which connect to the inferior vena cava. The flow of the veins are similar to the arteries, but in reverse. There's a segmental artery but no segmental vein. With each kidney there are about 1 million nephrons, and each nephron is made of a renal corpuscle and a renal tubule. The renal corpuscle is where blood filtration starts, and it includes the glomerulus, the tiny bed of capillaries, and the Bowman's capsule, which is made of renal cells that surround the glomerulus. As blood flows into the glomerulus, water and some solute in the blood as sodium are able to pass through the endothelial lining of the capillary, move across the basement membrane through the epithelial lining of the nephron, and finally into the bowel space of the nephron itself, at which point it is called filtrate. The epithelium of the nephron is made of specialized cells called podocytes, which wrap around the basement membrane like a tentacle of an octopus. Between these tentacle-like protections are tiny gaps called filtration, like a sieve, allowing only small particles such as water, glucose, and ionic pass through the white blood protein and red blood cell. As the filtrate leaves the Bowman's capsule, it flows into the renal tubule, which is surrounded by the peritubular capillaries. Now, before we dive too far in here, let's redraw the nephron so that the structure of the renal tubule is a little more accurate. Alright, so the renal tubule itself can be divided into the proximal convoluted tubule, the nephron loop, also known as the loop of Henle, which made up of the descending limb and the ascending limb, the distal convoluted tubule, and finally the collection duct, which ultimately sends the urine to the minor calyces. Here, the filtrate becomes fine-tuned based on what the body wants to give, versus it wants to discard with water solute, creating pass back filtrate into the lumen of the renal tubule and the blood into the peritubular capillaries. Each nephron also has a nearly unique region called the tetraglomerular complex, which is involved into the regulation of blood pressure and the glomerular filtration rate, or the amount of the blood that passes through the glomeruli. Each urine, the tetraglomerular complex is located between the distal convoluted tubule and the afferent artery. There are three types of cells in the tetraglomerular complex: macular denser cells, tetraglomerular cells, and extraglomerular cells, segmental cells. Macular denser cells are located in the distal convoluted, and they can levels of sodium and chloride. There are also the case of hypovolemia and hypotension. The macular denser cell sense the low sodium and chloride levels and send the signal over to the tetraglomerular cells with artery in the wall of the afferent artery. The extraglomerular mesenteric cells help with the signaling between the and tetraglomerular cell.